Good afternoon, everybody. As it was mentioned, I'm Eleonora Panizza, and I'm a PhD candidate at the University of Genoa and Cima Research Foundation. And I speak about an agent-based model we are developing for testing the impact of policy options on flood displacement into the IGAD region. So the activities I'm presenting to you today are part of a bigger program into the IGAD region, which is composed by 7 countries in Eastern Africa. And this project, which is called Addressing Drivers and Facilitating Safe, Orderly and Regular Migration in the Context of Disasters and Climate Change in the IGAD region, a quite long title, is divided into 4 pillars. Each of these pillars is coordinated by one UN agency. Cima Foundation is involved into the Pillar 1 data and knowledge activities, and the outcome in that case is that national governments into the IGAD region will have enhanced access to quality data and evidence on disaster displacement. There are 3 main outputs for this project. The first one is about disaster displacement risk assessment. The second one about decision-making model that I'm going to show you today. And the third one is about the capacity development component, which is the fact that IGAD and IPAC, which are the beneficiaries, will have capacity to use these methodologies and results to understand the problematic in the region.
Yeah. Sorry.
Concerning the first output, I'm not digging into it because it's not my field of expertise, due to the fact that it's a probabilistic model, and it's not the goal of this presentation, but just to give you an overall picture of what the project is. We started from the disaster displacement risk formula, so hazard per exposure per vulnerability. And in the context of displacement, vulnerability was considered just as vulnerability to concerning the housing component. So the previous approach considered people living in a house damaged over a certain threshold to be displaced. Now we are working with IDMC, which is the Internal Displacement Monitoring Center, to develop this approach, including other elements that can be important in order to understand the dynamic of displacement. Why? Because people don't need to move just because they lose their house. They can move also because they need, they lose, their job, so livelihoods and access to essential services, for example, health services or educational ones. So we added to the formula crop production loss, loss of grazing lands, damages to infrastructure and industries, in order to have a bigger picture on that. We used GLOPAS in order to develop flood risk scenarios, and based on that, to evaluate possible consequences on population, grazing land, infrastructure, and crops, as I mentioned before. On that basis, again, we evaluated the annual average number of people displaced in the region, and using a GIS, we developed these maps showing the number of possibly displaced people in each of the countries of the IGAD region. The total number, which is 1.35 million, is compliant with the data set that IDMC shared with us. So we are quite happy about the result of this first part of the project. But it's not enough because displacement, the displacement dynamics of the decision-making process It's not based only on loss of the house, loss of livelihood, or loss of access to services. There are also other elements that need to be taken into account and that we can't consider in a probabilistic model. And I mean, for example, interactions between people, the impact of policies on these dynamics, and perception, for example. That's why we have output 1.2 that is about a decision-making model that can capture also the other elements. On this output, we are working with several stakeholders and actors, mainly with the platform on disaster displacement, which is a partner of the project, and IGAD, which I already mentioned, but also individuals, in particular, Dr. Jared Abainea-Weber, which is working with us both on the data collection and data analysis part and on the model implementation, and local data collectors that help us in the field collecting data using questionnaires, as we will see in a second. What is the motivation for this output 1.2? The fact that there is still poor understanding of the impact of floods on human displacement, and mostly the impact of different policies on human behavior. That's why we are trying now to simulate people's behavior in different policy scenarios. So in each policy scenario, we try to understand what is the impact of one of the policy we can implement to reduce the risk of displacement. And the result of this analysis will support decision makers in the region to understand what can be the most adequate and the most efficient policies to address the problem. One of the first issues we needed to take into account was the selection of a pilot area. As I mentioned before, a probabilistic model was more at the national and subnational level. Now we are going deeper and we are trying to understand what are the interactions, what are the perceptions, the cultural elements in a specific area of the IGAD region. So we discussed and selected with stakeholders and also IGAD itself the possible location where to conduct this research. And these two villages, Wad Ramli and Al-Jaili, in the Khartoum state of Sudan, were selected. So with the help of data collectors, we deployed 300 more or less questionnaires that were divided into 3 sections. The first one was about household characteristics, so size, composition, their occupations, income, and so on. The second one about past experience concerning floods and displacement. And the third one about risk perception and, in general, availability to move and perception about displacement. I'm not showing you all the data because they are too much, but just to give you an idea. We found out that the average number of members, I'm sorry, I missed an element. The questionnaire were at the household level. So we collected information of the household and not of the individual. And we discovered that the average size of these households is 5 members. In addition, we have a pie representing the composition of these households. So the total population is composed by 30% children and 11% more or less elderly people. And these are the most vulnerable categories, we can say, to floods and displacements. So it is important for us to understand that. And also the disability component. So 13% of the total population has a disability. And this also is an important element to consider in the disaster displacement issue. Occupation, I'm not getting into it, but we collected information about different jobs that people are currently doing and the average household monthly income they have. The red line is the extremely poverty line. So above this threshold, they are really, really poor and have no means to move, actually. But I was talking about a person living there, and also the other range are not very much. So they are all poor, we can say, in this region. Going on the second section about flood experience and displacement experience, we asked them to report the number of floods they experienced while living in the place, in the current house. And most of them reported just one flood, but 65 of them reported the water level in the house to be at chest level, so very, very high. Then we asked them to say if they were displaced due to the flooding or not. 67% were displaced due to these floods. And we asked them also why, when, where, and for how long they were displaced. So the most important reason for displacement is flood damage to house, but we have also other important elements, for example, flood damage to sources of income, flood damage to critical infrastructure or to crops, and also fear to be affected by floods, so a sort of preventive movement. When they move, most of them move during the flood, and nobody, 5%, moved before, and it is really interesting to me. Where they move inside the village boundaries. Almost nobody moved outside the location, and nobody moved outside Sudan. And it is also really interesting. For how long? We have two main results. Many people are displaced for less than 5 months, sorry. But there are also people who are displaced between 1 year to 4 years. So there are two kinds of displacement, we can say, one shorter term and the other long term. Then we asked to people not displaced why they didn't do that. Many of them because they don't have insufficient income or means to do that. So they are, we can say, trapped. We can call them trapped populations because they are in the condition to leave, they need to leave, but they don't have the assets and income to do that, or because the damage was little, so that no need to move, or attachment to the place of residence, and so on. The third part was about risk perception, and it's one of the most interesting to me, because asking, for example, if the house was in a flood-prone area, if floods have changed in terms of frequency, intensity, and predictability, we can understand that in general they have a quite clear idea of the situations they are living. And also we asked to what degree they are at risk of being displaced due to flood, and to what degree they consider themselves to be at risk from flooding. And here again, many people reported to be at high risk or medium risk, and it is really interesting. Other two components are flood fear and availability to relocation. Many of them reported to be extremely or pretty scared about flood and also available to relocate. So after this presentation, I want to dig into the choice of the model. So we decided to implement a decision-making model, which is called agent-based model. It's a computational model for simulating interactions and actions between agents in an environment. And we decided to use this kind of methodology because it gives us the possibility to model complex systems and heterogeneous populations, and including those elements that we can capture with a probabilistic model. So, for example, perceptions, human interactions, people behaviors, and so on. So we can complement this kind of model, with the probabilistic one we implemented in the first part of the project. And this model can also give us the opportunity to provide policy analysis and support decision making. That is our final goal. So in order to implement an agent-based model, we need to understand what are the physical components we want to represent. Considering the area we are talking about, we are modeling the Nile River, which is one of the physical components we are including in the model, houses and IDP camps. So you can say displaced people in camp. There is one in the region. Livelihoods, so crops, livestock and industries, and critical services. Agents in this case are of two kinds. On the one hand, we have household agents. So based on the data of the questionnaire, we are representing these composite physical agents. So we are using the data of the questionnaire to represent the whole population of this location. And on the other side, we have the political agent, which is implementing policy to reduce, to address the problem of displacement. We have different properties of these agents. Concerning household, we have the elements we considered also in the first part of the project, so house characteristics, location, house materials, and this is important to understand the damage to the house. Then we have livelihoods, occupations, properties, average monthly income. So the livelihood component we consider also in the first part of the project, access to critical goods and services. What we added the left side of the screen, so risk perception and awareness, what people think about their condition, if they feel themselves to be at risk, if they want to move, if they are fear, and so on, and household characteristics. And these are the informations that we have through the questions we implemented. Concerning the political agent, due to the fact that we are not interested in representing a real political agent, but an abstract one, we are not interested in real characteristics of a real agent, but we are trying to characterize the political agent using the policies it implements. And their properties can be the typology, for example, if it is a preventive or an emergency measure, and the target group. For example, the policies can be applied to low-income people or to other groups. On the right side, you can see some of the possible policies that can be tested in the model. For example, the housing and planning policies. So working on the structural part of risk reduction, vulnerability reduction policies, for example, from the social economic point of view, early warning system that can be also a tool for evacuation. If people are warned and aware of the risk in advance, they can move preventively. Reallocation policy, and emergency management policies that can be applied after the flood. As a final issue, I wanted to show you a really synthetic flow chart, just to give you an idea of what can be the process in the agent-based model. The final flow chart will be much more complex than this one, but for today I tried to squeeze it. So using the questionnaire and information we collected, we included in this flow chart the elements relevant in order to understand the displacement, the decision-making process. So we included flood risk, risk perception, availability to move, interaction, income, in order to understand at the final of this flow chart if people move or stay. And this first slide represents the time before the flood. So what people do before the flood, if they move preventively, if they feel to be not safe, they try to find another place. taking into account the income they have, the relationships they have, the perception of their situation they have. In this context, we can apply, as I mentioned, different policies. I included in the slide some of them that can be tested inside the model in order to understand what is the difference. So what is the number of people that move? What is the number of people that stay? What changes if I implement a policies at this stage? Then we have the part after the flood. So we model a flood based on the information we have from the first part of the project, so globe files and risk profiles. We add to the agent-based model damages to house, damage to livelihood and properties that we know happened in the past, we can say. And from there, we try to understand how people move and how people will react, taking into account not only damages, but also risk perception, as I said before, interactions with other agents and so on. And here again, we can implement and test different policies that can change the final outcome of the flow chart of the model. As a conclusion, just a quick thought. So it is a big challenge to tackle disaster displacement and to model such a problem, because there are both environmental issues and social issues at the same time. So we try to use two different kinds of methodologies, a multidisciplinary approach. On the one hand, we have the more engineeristic and mathematical model, the probabilistic one, at the global level, and on the other side we have a more social science model that tries to go deeper and understand the underlying drivers of displacement. So we try to mix both and understand what will happen and what are the best policies for the region we are considering. At the end, we will share with beneficiaries which are involved throughout the project, all the results, all the models, methodologies, and the idea is that they can reproduce this model, this research in other locations inside the IGAD region in order to produce other model, other results. So that's all from my side. There was my email, but I don't know.
Are there any questions for Eleonora? Yeah, I'm curious if, like thinking back at the end of this presentation earlier and forecast-based financing, would your model then predict if we had additional funding available for people to move, would that impact and how much investment might it take to do that?
Yeah, that can be an option. For example, one of the policies under the vulnerability reduction tax, you can say, is income policies, for example, or insurance. So if we have insurance or a certain minimum level of income for all these people, what can happen? They need to move, they all move, or they decide not to do that because, I don't know, they have a farm there, they don't want to move because they are attached to the place. But we understand what will happen if we remove this not enough income to do that, actually. So yes, this can be an option.
By the way.
Sorry?
Excellent work. This is really hard to combine all of those things. Really,
Thanks so much.
You could actually have more people displaced if you provide more income to them. Is that one of the conclusions?
Yes, and yeah, thanks for the inputs. One of the criticalities or things we have to understand is how to distinguish between evacuated people and displaced people, because displaced people are in emergency situation or bad condition, you can say, evacuated in a sense is a positive outcome because they move in a safe condition. So in the model, we have to understand how to distinguish these two type of movement. Yeah.
It makes me think of a situation we're in Tanzania, we're working with Jordan. And they offered nice housing to people also to move away from the city center to away from the river to a safe place, but they're also on the outskirts and there was very little work. So in the end, what they did, they had to arrange their own income living like that. That we worked in the city center. It's really difficult.
Thank you.